on James Webb Telescope, possibly capturing the first image of a terrifying black hole. To compare it to its predecessor, the Old Man Hubble, the James Webb Space Telescope, or JWST, or just Webb, will allow us to grasp the cosmos as it was immediately after the Big Bang. Webb was conceived as a next-generation space telescope and was named after NASA pioneer James Webb. 6 years later, with the help of European and Canadian space organizations, NASA planned to launch the JWST in 2007, which was of course 14 years away due to the difference between the new marvel and the Hubble Space Telescope. In this sense, NASA prefers to refer to JWST as the successor to Hubble rather than a replacement because it is specific to visible light wavelengths and has a somewhat limited range of ultraviolet and infrared wavelengths. Actually, the cosmic rule credited to Edwin Hubble and others was established by noting that galaxy redshift is precisely proportional to their distance from Earth, which the Hubble telescope investigated to the best of its abilities. This means it can view the light from stars and galaxies that existed more than 13 billion years ago, thus making the telescope a time machine. Regardless of Hubble's ability, JWST will be able to see considerably larger distances and go back in time than Hubble, and its light-gathering capabilities will significantly exceed Hubble's. When comparing the diameters of a softball and an NBA basketball, you can see the size difference by utilizing the webbed mirror, which is substantially larger and 100 times more powerful. Furthermore, throughout Hubble's 30 years circling the planet, the Webb had a field of view roughly 15 times larger than Hubble's. Even when there is modest heat emission, it is hard to distinguish infrared sources that are far farther away from us. At the second Lagrange point, where the JWST will orbit the Sun from a distance of 1.5 million kilometers. As a result, for optimal performance, the JWST must be kept at minus 233 degrees Celsius or minus 388 degrees Fahrenheit. That is, after all, why the JWST took 3 decades and cost $10 billion to complete. Before reaching operating temperature, the JWST will be in orbit for many weeks, and then for around 6 months before regular scientific operations begin. A team of 50 researchers will investigate approximately 5,000 galaxies, including an unprecedented 320 in the mid-infrared, throughout the 208.6 hours of scheduled observing hours to understand more about how our universe originated. Furthermore, as soon as feasible, Webb will post jaw-dropping eye-delight images. Isn't it true that we now have images of black holes? Since light cannot escape their grip, none of them are totally correct. The monster in the center of the galaxy, M87, captured by the Event Horizon Telescope (EHT) project in 2019, is the closest thing we have from Earth. Quasars are supermassive black holes that are actively feeding on enough surrounding matter to generate a light that is so bright that it outshines the rest of the galaxy, according to researchers. Even more recently, in early 2021, the EHT project, which uses 8 radio telescopes from across the world to form a virtual Earth-sized megascope, obtained a polarized light image of the center of the M87 galaxy. Consider combining this planetary megascope with Webb space capabilities. The JWST will undoubtedly work with the EHT project to capture the first image of a Sagittarius star, or SGR star, in our own Milky Way galaxy. The JWST is expected to provide astronomers with a spectacular picture of the flashing flares that are routinely released from our galaxy center, something that M87 has yet to discover. This isn't even the most outlandish black hole exploration Webb has planned. According to NASA, the universe is 13.8 billion years old, and scientists have identified 3 huge quasars, more than 13 billion light-years distant from Earth. The JWST will explore these objects with billions of solar masses that date back to the birth of the cosmos. Since they were discovered nearly 2 decades ago, the number of verified exoplanets has surpassed 4,000, and the total is nearly doubling every 27 months. The JWST is about to reveal far more about these other worlds than we currently know, as it analyzes their atmospheres and even looks for the building blocks of life. One possibility is to combine ground-based observatories with a transit method, which looks for the dimming of a star's light when a planet passes between it and the star. Webb will help determine the planet's mass and provide spectroscopy of its atmosphere. When a planet passes in front of a star, the star's light travels through the planet's atmosphere, and if the planet's atmosphere contains sodium, an absorption line will appear in the area of the spectrum where we would expect to observe sodium when the spectra of the star and the planet are combined. This is because different elements and molecules absorb light at different energies, which is how we know we're on the spectrum. As a biomarker, we may see sodium, methane, carbon dioxide, or even water. Dr. Marcia Reichel, a professor at the University of Arizona and the primary investigator of the JWST's NIRCam near-infrared camera, believes that we may not find only new planets, but planets with atmospheres similar to ours. The telescope is scheduled to make its first observations about 6 months after launch, and from there, we will see what this space observatory is made of. After all the anticipation, the first photographs will be well worth the wait. It will look into more than just things, from the outer planets to Kuiper Belt objects and asteroids. Our own backyard will be revealed in ways we could never have imagined 13 billion light-years distant. Everything has been taken care of. The JWST will give us a fresh look at our celestial companions. Scientists will be able to look at the composition of surface ices and volatiles on a number of planets in our solar system, as well as a new class of icy comets in the asteroid belt. And as Dr. Klaus Pontoppidan, an astronomer with the Space Telescope Science Institute, said at a recent news conference, the telescope was built to answer questions we didn't know we had. Thank you for sticking with me to the end. Comment down below. What do you think about this new telescope? Finally, click on the like button if you enjoyed the video. Subscribe to the channel if you liked our content to show your support, and press the bell icon so that you never miss a video from TechBomb.